Hi again, everyone. Chris Tisdell here again. Thanks for tuning in. In this presentation, I'm going to continue my live streams of mathematics, and I'm going to discuss a method of integration that involves an idea called partial fraction decomposition. Now, although that sounds very abstract, it's just a little bit of algebraic manipulation to put the integral into an easier form. So I'm going to discuss an example and sort of talk about some of the ideas. So let me share my screen with you. This is the example we're going to discuss. You've got this indefinite integral denoted, say, by I. You've got a linear function up the top. You've got a couple of factors down the bottom. You've got a linear factor here and a linear factor here and a square of that linear factor. Okay, now this is a special kind of denominator here where this linear factor x minus 2 has a squared here, so it's known as a repeated linear factor. Okay, so how do I actually start to integrate this expression? Because it's not easy, right? The top part's a linear function, the bottom part's essentially some sort of quadratic, some sort of cubic. So what do we do? Well, the bottom sort of factorization gives us a bit of a hint. If I have, say, a constant over x plus 1, I know the integral of that. And if I have a constant over x minus 2 or x minus 2 all squared, I know how to integrate that. So what we're going to do is use these bottom parts as a guide to break this down into the sum of something simpler where this, and the whole squared is in the denominator. Okay, so let me share that with you. All right, so let me write this out. All right, now the claim is the following. I can find a number A, a number B, and a number C such that the following is true. Now notice the sort of change here in the denominator, right? You've got that sort of just sitting by itself, okay? You've got a constant on top of that. You've got this here squared, and you start sort of with this to the power 1, and you go up to a squared, okay? Now, if this was a cubed up here, you'd have this, and then a d over x minus 2 all cubed. Now, we'll check that this is a bona fide representation a bit later. If I covered up that squared, you would just have that, covered up the squared, this c term would not, essentially would be 0. Okay, so if there's a repeated linear factor, you need to be a little bit careful. It's not quite as simple as you might think. Okay, so how can I find this A, B, and C? Well, I'm glad you asked. That is the key to getting the precise answer for this problem. Okay, and it just uses a little bit of algebraic manipulation. So what is it? Well, firstly, before we find A, B, and C, just, students do these problems, or they try to do these problems, and if they can't get A, B, and C, they give up, right? If you can write this as this, and A, B, and C are constants, you can integrate this, and integrate this. This is going to give you A log x plus 1. This is going to give you B log x minus 2, and this is going to give you something like negative C all over x minus 2. So you can actually still perform the integration. You just don't know what A, B, and C are. So that's a little bit of a trick to get some part marks, because at the end of the day, we're testing integration here, okay? Not really algebra, even though that's an enormous part of the solution to this problem. Okay, so let's get back to it. What I'm going to do, I'm going to take this denominator over here, and I'm going to multiply both sides of this expression by that denominator. So let's call this, say, this whole expression star. Oh, hang on, let me just zoom out a bit. Yep. So let's call that expression star. All right, so let's just make a little note. I'm going to multiply both sides of star by this denominator. Okay, so this is where the algebra comes in. Okay, so what's going to happen? Well, this is going to disappear, of course, and then I need to multiply both sides over here. So when I multiply this by here, the x plus 1s will cancel. So I'll be left with a times x minus 2 all squared. In this term, this whole thing times this, one of the x minus 2s will cancel. So I'll get b times x plus 1 times x minus 2. And over here, this times this, both of the x minus 2s will cancel. So it'll be c times x plus 1. Okay, so on the left-hand side will just be 5x minus 4. Okay, let me move that up. All right, so the x plus 1s will cancel. One of the x minus 2s will cancel there. And both of the x minus 2s will cancel there, and I'll be left with c times x plus 1. Okay, so let me just box that up because that's an important expression which we'll be able to get our unknown a, b, and c from. Okay, so now the focus is on trying to get a, b, and c. So how do you do it? Well, there are various ways to do this, and you know, there's the Heaviside cover-up method. There's the method of undetermined coefficients. What we're going to do in the box expression is just sub in some values for x. Okay, some strategic values that simplify things. So let me show that. Okay, so firstly, if I want to, this looks like a complicated mess, but if I want to simplify this, let's consider plugging in x equals 2, positive 2, x equals positive 2. If that's the case, then this will go to 0, this will go to 0, and I'll be left with c, 3c over here, and something over here. That will give me the value of c. Okay, so let's plug that in. So if x equals 2, I know if plugging in x equals 2, that'll disappear, and I'll be left with this. The left-hand side will be 10 minus 4, which gives you 6. And on the right-hand side, I'm going to have 3 times c. So c is 2. What else can we do here? Well, if I plug in x equals minus 1, that bracket will disappear. That bracket, or this term, will disappear. And I'll be left with something involving a. So let's do that now. X equals negative 1, yes? That'll disappear, and let's find out what we have. All right, so I'll get negative 5 minus 4, negative 9. And on the right-hand side, that's 0, and I get a times negative 3 all squared. So that'll be 9a. So a equals negative 1. All right. Now, lastly, there's no real strategic choice left, but a simple value for x is x equals 0. I mean, that'll disappear. Sorry, the 5x will disappear then, and some of these x's will disappear. So when it's not clear what to do, I'm just going to choose x equals 0 kind of as a default. So if x equals 0, then, okay, so I'll get negative 4 on the left-hand side. I'll get 4 squared there, which, negative 2 squared there, which will be 4a. Here I'll get negative 2b. And down here I'll get 1c. Now we know what c and a are. So c will, I'll replace that with 2, and replace a with negative 1. So what we're trying to do here is get B. All right, so if I rearrange this, the negative 4's cancel. Take that to the other side. I'll get something like 2B equals 2. So let me see if I can squeeze it in. B equals 1. All right, so let me box those up and see how we go. So C equals 2, A equals -1, and I've just squeezed this in here. B equals +1. So now I can take those back to up here and integrate each of these things separately for a particular A, B, and C. Okay, so let me take a new page and we can do that. All right. So last part of the problem now, the actual integration. All right, so A is -1. Oh, actually, I won't write the dx in there yet. B was +1. And C was +2. Okay, all right, a bit messy. Now this is going to be a log, this is going to be a log, this is going to be something like negative something on x minus 2. Okay, so let's write that down more precisely. This will be negative log absolute x plus 1. This will be log absolute x minus 2. And you can combine these if you want to via log laws. And this will be something like something over x minus 2 with a negative. It's just the following. Okay, plus say a constant, let's say k. So let me box that up because that's going to be our answer. And let's just identify that k is a constant. All right, so we're really happy. We're really happy. Okay, so let's just run through that one more time quickly, and then I'll give you some justification on why the form is the way it is. All right, we were given this problem here. We identified a repeated linear factor down the bottom. We said, all right, let's try to break that up into 3 different bits, okay, for some number A, B, and C. I used algebra to find A and B, firstly by simplifying through a multiplication, and then by strategically subbing in values of x. Okay, I got these values for A, B, and C. Lastly, I did the integration. I wrote it out as 3 bits and did the integration 3 times. Okay. So why does that particular form work? So let me just share. This is something that I've created earlier. What I'm going to do is kind of work backwards. All right. So I'm going to start with a form that we had, and I'm going to work backwards. All right. So what I'm going to do firstly is cross multiply here and here and down here. So put these 2 terms over the one denominator. All right, so I'm just checking now to actually give a little bit of justification. All right, so that times that plus that times that all over the product of the 2 denominators. You get something like this. That's a 2, by the way. Okay, now what I can do is, of course, strike off one of these common factors of x minus 2. And I'll get the following. Okay. Yes, all right, so I'm going to be left with x minus 2 plus 2. Now, obviously, that's going to, the negative 2, that negative 2 and the positive 2 are going to disappear, and I get that. Now, let's do the same sort of cross multiplication with these 2 terms. All right, so that times that times that over the product of the denominators. Okay, so that times that, that's negative up there, of course. plus that times that, you get this, times it all over this. Now we're getting very close to what we started with, okay? We're getting very close to what we started with, okay? We want to basically end up with what's in here. So you can see here we've got the same denominator down here. We just want to make sure that this up here reduces down to 5x minus 4. So if you expand this bracket, the negative x squared and the positive x squared are going to cancel each other out. And you'll be left with this, and that is 5x minus 4 over the usual thing that we wanted. Okay, so this form really does, really is equal to this form that we started with. Okay, so that's one of the more involved method of partial fractions for integration where you have a repeated linear factor. Now there are other quick methods like the Heaviside cover-up method that I've described in other videos, but this one's a little bit trickier because you do have that repeated linear factor. Anyway, hope you enjoyed this video, hope you found it useful. Please join me for more live streams in the future. If you have any comments, any questions, I would love to hear them. So post a comment or you can always send me a message. Thanks for watching, everyone. See you all later. Bye.